Hi, and thanks for joining me for another little chemistry tale. In this video, we're going to be looking at how we are able to obtain the molecular formula once we have calculated the empirical formula. So calculating or determining your empirical formula would be the first step, and getting the molecular formula would be the second step. So the first thing you need to do is find the molar mass of the empirical formula. So if I have a chain and I take the mass of my chain and I divide it by the mass of each link in that chain, I'm going to get the number of links that make up my chain. That's the analogy for what we're doing here. So if you know your whole mass, so if you know the mass of the whole chain, you know the mass of a link. If you divided those, you would find out you had 5 links. So that's what we're trying to find here, is how many of these links or empirical formula units we have. You will be given the molecular mass of the entire molecule in the context of this question typically. There are a few times, certainly more at the college AP IB level, where you would have to calculate the molecular or molar mass from using a different kind of math, or different, maybe it's a gas law problem and you might use Pevner to find an unknown molar mass, for example. Or in the case of IB, maybe they give you a mass spectrum and you have to find the molar mass of the whole compound from the mass spectrum. So there are ways to do that, but initially we're going to start assuming we're given that. So our number of links is going to be the molar mass of the molecule divided by the molar mass of the empirical formula. So I have an empirical formula, and that is C2H4O. And so if I want to find the number of those empirical formula units, now a lot of textbooks won't call that anything. I like to call them empirical formula units. The number of those is the molar mass of the molecule, which is given is 132.16. Now, to calculate my molar mass of my empirical formula, I do just like I do any molar mass. I take 2 carbons, and I take 4 hydrogens, and I take 1 oxygen, just like you would do any molar mass. And if you do that, you get 44.06. And you will get a whole number here. There's no multiplying till whole at this point. You should get a whole number, or there's a problem somewhere along in the calculation. And this is 3. So that means I have 3 of these C2H4O little empirical links. So I'm going to multiply the 2 by 3, the 4 by 3, and the 1 by 3. Remember, 1 for all for 1. And so my answer is going to be C6. You have to, complete that math. You can't leave it as this is your final answer. That's not your final answer. Your final answer is C6H12O3. You have to write the final molecular full formula there in order to get credit for that. Okay, let's do one more. We have, again, another empirical formula. Doesn't give you a whole lot of information. We have another CH2O. This time it's molar mass, so my number of empirical formula units, the count of these that I have is going to be the molar mass of my molecule divided by the molar mass, 1 carbon, 2 hydrogens, 1 oxygen, is 30. It's 30.03, but this is going to be close enough, and that's 8. So that means I need 8 of these empirical formula units to give me my final molecule. So 8 carbons, 8 times 1, 16 hydrogens, 8 times 2, and 8 oxygens, 8 again times the implied 1 there. And that would be my final molecular formula. So thanks for joining me. I hope that clarified any misconceptions or helped you understand this concept a little bit better. Take care. Have a good day.